Hello everyone, welcome back. In this video, we'll be taking a look at bounds. So let's define it this way. So let S be a subset of any ordered field. Then the upper bound of that ordered field, or for the order of that field, is any number which is greater than or equal to all elements of that set. So, for example, if you take the number line to be like this. So you take 1, 2, 3, and we say the subset ends here. Then any number 4, 5, 6, 1,000, a million, all of this count as upper bounds. Whereas for a lower bound, if we take a subset such as if we take the set 1, 2, 3 as the set, then 4, 5, 6 and 3 are the upper bounds. So any number that is bigger than or equal to all elements in the set is called an upper bound. And similarly, a lower bound is any number that's lower than or equal to any number in the element will be a lower bound. So for example, in this set, 1 will be a lower bound, so will 0, so will -1, so will -2, so will a -1 trillion. All of them qualify as lower bounds for this set. So what is a maximum? Well, maximum is the upper bound of a set which is in S. So for example, so maximum of S, a subset S, is the upper bound of S which is in S. So for example, if we consider this set, the maximum of this set is the upper bound which is inside S. So in this case, the element 3 is a maximum, and the minimum similarly is a lower bound of S which is inside S. So in this case, 1 is a lower bound. So remember that some sets do not have any upper bound, any maximums or lower bound. Any maximums or minimums. So before we take a look at any examples, let's go over what supremum and infimum is. So before that, let's take, we say any set S is bounded above if it has an upper bound, and we say if it's bounded below if it has a lower bound. So note that some sets do not have upper bounds and lower bounds. For example, consider this set to infinity. This set has no upper bound or lower bound, because we can always find a number which is greater. We can always find a number because this set goes on and on and on. We can never find a number which is greater than or equal to infinity. So some sets are bounded above and some sets are bounded below. And in the case that they're both bounded above and bounded below, i.e., they have both upper bounds and lower bounds, then we say the set is bounded as a whole. So what's the supremum? Well, the supremum is the least upper bound. So if in the previous case, if we consider the set 1, 2, 3, we notice that they have millions and millions, an infinite amount of upper bounds, but the least upper bound for this set is 3. So 3 is the supremum of this set, and the infimum similarly is the greatest. It's the greatest lower bound, and in this case it's 1. We notice that there are so infinite amounts of lower bounds such as 0, -1, -1 million, -1,000, but the greatest of the lower bounds is 1. So 1 is the infimum of this set, and so is 3, and so is 3 is the supremum of the same set. So let's take a look at some interval notation before we dive into some examples. So interval notation, whenever you notice these square looking brackets, that means it's greater than or equal to. So for example, if you consider this 1, 2, that means this set includes both 1 and 2. If you consider 0, 1, 2, 3, 4, 5. Right, if you consider this set 1, 2 with the square brackets, that means this set includes both 1 and 2. Whereas if you consider the set AB with a round bracket, then the set does not include 2. So if we consider this set 1, 4. Then this set includes 1, 2, 3, but it does not include 4. It goes up to, but not including 4. And if you have rounded brackets on both sides, then for example, if you take this, then this set doesn't include 1 either. It'll include 2, 3, and that's it. And all the elements between 3.8, 3.9, 3.9999, but it will not include 4, and so also it will not include 1. So when you have rounded brackets, that means its a is less than x less than b, it's not equal to b. And if you have such a scenario where it says a to infinity, that means x is greater than a, and there's no limit to it as it's infinite. You can go on and on and on. But if you have such a case like this, then its x is greater than or equal to a. Please note that you'll never find a situation such as this. An infinite set you cannot include infinity in a set because infinity is undefined. We don't know what it is, so it's never bounded by. You can never have a square brackets with infinity. So let's take a look at some examples to make all this more clear. So we're told to find the minimum, maximum, supremum, and the infimum of this following set. So whenever you're doing such questions, it's always good to draw it on a number line to see what is happening. So we're told that these two elements union 0, 4. So if we write this as such a way, let me draw the number line to make this less blurry and see what's happening. So we're told both -1 and 3 are in the set, and its union with 0 to 4. So since it's rounded brackets, we just draw circles. We don't shade the circles inside. So it's going up till 4, but it's not including 4. For this, so in this case, 4.1 is upper bound, 4.2 is upper bound, 5 is upper bound, 6 is upper bound, but 4 is also an upper bound, but it's not the maximum, because maximum means it has to be in the set, but this set goes up till 4 but does not include 4. So the maximum of this set does not exist, and the minimum of the set, it exists. It is -1. Remember, minimum of the set is a lower bound which is inside the set. So -1 is certainly a lower bound, and it is in S. It is in the set S. So the minimum is -1. The supremum of the set is 4. So remember that it doesn't matter. Supremum is defined in such a way. Supremum is the least upper bound. It's not an upper bound that should be in the set. So supremum gives us a lot more freedom. So supremum just a supremum of a set should just satisfy the condition. It should just satisfy the two conditions, that it is the upper bound and it is the least upper bound. So 4 is certainly an upper bound, and it's also the least upper bound. You can't find another element which is lower than 4 and is also the upper bound. So 4 is the least upper bound, and the infimum of the set is also -1, because it is the greatest lower bound. You can't find a lower bound for this set S which is greater than -1. So this is the answer for this. Let's take a look at another example. Alright, sorry about that. So we're told to find the minimum, maximum, supremum, and infimum for this rather simple set, -4, 2, but with round brackets. So in the number line, it'll sort of look like this. So remember, it's always good to draw the number line and see what's happening, which will make your answers, which will make you much more confident in answering such questions. So we're told that it includes -4, but it only goes up to and not including 2. Therefore, we just draw a circle which is not shaded inside. So the maximum of this set is not included in it, and the minimum of the set, it is a lower bound which is in the set. In this case, -4 is a lower bound. -4 is a lower bound because a lower bound means a lower bound means that it is an element such that it's less than or equal to all other elements in the set. -4 is less than or equal to all the other elements in the set. So therefore it's a lower bound, and it is also in the set. Therefore the minimum exists. Sorry, the maximum does not exist. I'm really sorry about that, because it goes up to but does not include 2. If it was in such a case where -4, 2 with a square bracket, then the maximum would exist because it's upper bound which is in the set. But the element 2 is not in the set. Therefore, the maximum does not exist. And the supremum is 2, and infimum is -4. For supremum is the greatest lower bound. It's the least lower bound, and infimum is the greatest lower bound. So supremum is the greatest lowest upper bound. Sorry about that. Supremum is the lowest upper bound, and 2 is the upper bound for the set because it's greater than or equal to all other. It's greater than or equal to all other elements, and it is the least upper bound. So for example, 3 is upper bound, 4 is upper bound, but 2 is the least upper bound. So is the infimum. Infimum, -5 is a lower bound, -6 is a lower bound, but the infimum -4 is the greatest lower bound. So it meets the two conditions. Therefore, supremum is 2, infimum is -4. So let's take a look at this case. So this says S is a subset such that it's 1 over n for all natural numbers. So what are the natural numbers? If you remember from previous videos, they start from 1, 2, 3, 4, 5, and so on and so forth. So in this case, the set S will be defined as 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5, and so on and so forth. So this is just 1, 0.5, 0.2, 0.33, 0.25, 0.20. So they're getting smaller and smaller as you go on and on. So what is the maximum, minimum, the supremum, and the infimum? So the maximum it's the upper bound which is in the set. So the upper bound for this set is 1, and 1 is in the set, therefore the maximum is 1. And the supremum is also 1 because it is the greatest upper bound, it's the lowest upper bound. And for in this case, 2 is upper bound, 3 is upper bound, but 1 is certainly the lowest upper bound. And in this case, minimum does not exist, and the infimum is 0. And why is this? Because we can see they're becoming closer and closer to 0, and they're approaching 0, but they will never be equal to 0. No element in the set S will be equal to 0, because the natural numbers will go on and on and on and on. So the set S will become smaller and smaller and smaller and smaller, but it will never be equal to 0. It will become 0.000 trillions of zeros and then 1, but it will never be equal to 0. So therefore 0 is not in the set. Even though 0 is a lower bound, 0 is not in the set. Therefore the minimum does not exist, and the infimum is 0, because 0 is certainly a lower bound, and it is the greatest lower bound. So I want you guys to note one more fact before we end the video. So whenever a minimum exists or a maximum exists, then the minimum is equal to the infimum. So in this case, the minimum does not exist. So the infimum is different from the minimum. But whenever the minimum or the maximum exists, the maximum and supremum are always the same. So in this case, the maximum is equal to 1, then the supremum is equal to 1 too. In the previous part B, the minimum is -4, the infimum is also -4. So whenever the minimum exists, the infimum is equal to the minimum, and whenever the maximum exists, the maximum is equal to the maximum is equal to the supremum. So hope you guys enjoyed this video. See you next time.